Hello, in this last video on complex numbers, I'm going to work an example like you might find in your textbook. A little more complex one than we worked in the other ones. I'm going to do every step. So here's our problem. 2 times the square root of minus 4 times the square root of 2 plus 3i times the square root of 2 minus the square root of negative 4 times the square root of 2. What does that equal? We want to come up with a simplified complex number as our example, which, as you remember, is going to be in the form a plus bi. So we have 2, let me make that a little darker, times the square root of 4 times the square root of minus 1. That gives us the square root of minus 4 times the square root of 2. Plus, there's really nothing we can do with that. 3i square root of 2. It's done with us, but these things appear in the textbooks. And then we're going to subtract the square root of 4 times the square root of minus 1 times the square root of 2. So this gives us 2. The square root of 4 is 2. The square root of minus 1 is I. And then we're just left with a plain old square root of 2. And then the second one is 3i times the square root of 2. And then the last term is the square root of 4, which is 2, times the square root of minus 1, which is I, times plain old square root of 2. We're almost home free. So here we have 2 times 2 is 4, times the square root of 2, and remember I goes outside the radical and at the end in my textbook, plus, oh here, except for here, where they have 3i, square roots of 2. You never know. Remember, multiplication is commutative. And then we have, let's just do it that way, 2i square roots of 2. So if I had written this in this form, it would have been 4i square roots of 2 minus 2i square roots of 2 leaves us with 2i square roots of 2 plus 3i square roots of 2, and then we have 2i plus 3i equals 5i square roots of 2. So this is an imaginary number without a real component, and that's the way we solve that. Just at the end of this, remember that when you work with a square root, like square root of a times b is equal to the square root of a times the square root of b. And this is the principle that we're using to break a negative number under the radical sign into a positive number and the square root of minus 1. Because negative 4, so the square root of 4 times minus 1 equals the square root of 4 times the square root of minus 1, which is 2i, but on this side it's also equal to the square root of minus 4. I hope that helps.